Hello, I'd like to take some time out to discuss industrial power quality applications. Why is a power quality analyzer even needed, and what type may you need? So, why do you even need a power quality analyzer in industrial applications? What's the benefit? The goal of any industrial site is to efficiently produce sellable product at the lowest cost while maintaining quality and achieving maximum margin. So, how is this done? Well, for starters, we want to streamline production. We also want to reduce cost. And we want to increase reliability. Streamlining production can include capital investments on new high-tech equipment. This equipment can speed up production. However, we do want to keep in mind that an electrical system is a dynamic system. When a new piece of equipment is added to that system, it's not only the new equipment that can be affected by that system, but the new equipment can affect the electrical system. Advanced equipment can be susceptible not only to voltage dips and voltage swells, but also transients, harmonics, and interharmonics, and that's just to name a few. The new equipment can also cause power quality issues that can affect other equipment. High-speed manufacturing equipment will also produce high-speed switching. Variable frequency drives save power, but they also produce harmonics. New equipment can also change the inductance on a system that can lead to power factor issues, which can cause power factor penalties. This is why it's imperative to perform a power quality analysis before and after a new piece of equipment is installed. Perform the test before installing the equipment to verify power quality is within the recommended standards. Perform the test after installation of the equipment to verify the power quality is still within recommended standards. Investing in capital equipment to improve production is useless if it causes more problems. Manufacturing managers have a battle to reduce overhead costs. The reason's obvious. High manufacturing overhead has a dramatic effect on profit and competitiveness. Average burden rates, this is the ratio of overhead cost to direct labor costs, are 150% to 250%, with some plants burden rates as high as 1,000%. So how is cost and overhead reduced? The issue with overhead reduction is how it's done. It's often in response to poor earnings and provides short-lived savings. Overhead reductions can include cuts to activities like training programs, advertising, maintenance, or overtime pay. These cuts are usually restored after the crisis has passed, so the savings tend to be short-lived. This ignores long-term cost-saving potential. In addition, employees will perceive such actions as unfair and arbitrary. They can end up overburdened, which causes frustration and can lead to a demoralized workforce. So where can long-term cost savings occur? Now, direct labor can be reduced by adding automation. However, as mentioned previously, this must be done with caution as to not cause power quality issues or be affected by power quality issues. In addition, automation can reduce direct labor costs, but may very well increase overhead costs, since they may require more skilled maintenance. A large portion of overhead facilities cost is the electricity used to operate the factory equipment, as well as the depreciation on factory equipment. And maintenance. Reducing energy costs is a long-term overhead reduction that can be beneficial to both management and labor. Performing annual energy audits is a way to determine where you can save the energy. Industrial energy is used based on demand rate. A distribution demand charge applies to both commercial and industrial entities that pay time of use rates or have certain bill sizes. It is based upon the highest amount of power drawn during any demand interval during the billing period. The more electricity you request during peak periods, the higher your demand charge can be. Demand charges can comprise between 30 and 70% of a company's electrical bill. This interval can be based on a 15-minute fixed interval, but not always. For example, the interval can be 30 minutes. Or they can be fixed or sliding intervals. Most meters don't allow you the flexibility to match your revenue meter's aggregation rate. MPQ does allow this. Without this, you don't get the proper answer and cannot perform an adequate energy audit. Now, savings can be made by reducing heating and cooling, as well as changing to more efficient lighting systems. This can also be beneficial to employees' well-being. Poor lighting or flickering lighting can cause irritations and distractions. Many power quality analyzers measure flicker, but this only applies to incandescent lighting. You also need to be able to measure rapid voltage change, as well as harmonics and interharmonics. This is needed in order to diagnose lighting issues in other types of lighting systems, such as fluorescent and LED. Power factor penalties. When equipment is starting up, it'll often add an inductive load to the system. This will cause phase shifts that will lower the power factor. When the power factor drops too low, you can incur power factor penalties from your utility. These are costs that can be easily avoided by annual energy analysis. Often, in an attempt to reduce overhead, maintenance is cut. It may be moved to a third-party contractor, or it may be reduced entirely. When maintenance is reduced, so is reliability. How much will it cost if production shuts down? How much does it cost per minute? And this brings us to our third item, reliability. The less reliable the production, the less revenue is generated. This is why an annual power quality analysis is essential. This can be thought of as a doctor's appointment. Is it cheaper to have an annual checkup and address issues early, or have an emergency trip to the hospital? If you're not performing an annual power quality checkup, then it's just a matter of time. It could be days, it could be years, but it will happen. And what will that cost? In addition, a depreciation is assigned to factory equipment. This means it depreciates in value for every year of its life. Now, this assumes a lifespan for that equipment. If equipment's not properly maintained, then it will have a reduced lifespan. Power quality issues such as swells and transients break down insulation. Harmonics generate heat in systems, vibrations in motors, timing errors, as well as controller failures. And of course, voltage dips can cause equipment to go offline. And there's also unbalance that can generate heating effects in motors. All these items contribute to lower lifespan. So it all comes down to return on investment. You can always buy a bargain PQ analyzer. It will record basic power quality, but supports no advanced features. So why pay the extra money? It's simple. The less smarts in the analyzer, the more power quality expertise is needed by the end user. For example, if you're examining a power quality complaint, do you know how to program the instrument? Do you know what you're looking for? If the answer is no, then that bargain piece of equipment is just a waste of money. With the MPQ, you do not need to know everything. You simply connect the MPQ. It tells you if you're connected correctly. Have you ever connected a unit incorrectly? If so, then you know all your power and energy data you collect is wrong. The MPQ sets up its own limits based on standards. If you set them and you set them wrong, you will miss the critical data. That makes the whole recording a waste of time. And after you get the data, you need to analyze it. How long does this take? The MPQ does this automatically. So how much time does this save each and every time you use the instrument? No need for contractors, no need for wasted time, no need for wasted money. So, how do you use a smart analyzer? Simply connect the analyzer, select the desired setup or configuration. There's no need to create setup files unless you want to. Set your CT range on your 4-range CT. Press the button and start recording. The MPQ analyzer will automatically identify the selected range on the connected current clamps. It'll let you know if it's connected incorrectly, and the MPQ analyzer will now measure the line voltage and frequency and automatically set up all its event limits. The MPQ then starts recording. It will record all power and energy parameters, all PQ parameters, all PQ events. It will record all event waveforms, and even record timed waveforms like a recording scope. It records everything at the same time, so you will not miss a thing. Then we have an automated data analysis. The auto data analysis allows you to analyze the recorded data based on templates. Just select your desired template. It can be a standard IEC 6150 test, it can be an IEEE 1159 or 519 analysis, or you can create your own template based on your own requirements. The software then automatically analyzes the data. It'll let you know what parameters pass and which ones fail. If there's a single standard you always use, then you can select that as the preferred template. Simply select the data file, then click on the Preferred Analysis button. And just like that, you get your automated analysis. You then can create a data analysis report in seconds. The report will also include a subIMA chart. This allows you to view all recorded events and see which ones could be causing computer or controller problems. The MPQ is an instrument no industrial site should be without. The built-in intelligence will allow you to take control of your facility's maintenance. It will allow you to increase reliability and decrease cost. Thank you for your time and have a great day.